everybody. So in this video, we're talking about graphing linear inequalities. So they just say, graph the following linear inequality. Graphing an inequality is very similar to graphing a linear equation. So we are going to draw a line, but you have to think about what we've been talking about with absolute value inequalities and compound inequalities, or any inequality in general. Inequalities have lots of solutions. So how do I illustrate lots of solutions on a graph? Well, let's talk about that. So the first thing we're going to do is we're going to try to put this in slope-intercept form. So we remember what that is. That is y equals mx plus b. And we're not going to have an equal sign. We're going to have an inequality. But the format's the same. So let's start by moving 5x to the other side. And then we're going to set this up. So now we have negative 2y is less than. We want the x to go in front because that's our slope. So here we're going to say negative 5x plus 12, and we want y by itself. So here we're going to have to divide by the coefficient in front of y. So we are going to divide by this negative 2. So here we'll divide everything by negative 2. Now, our rules to inequalities have not changed. Remember, anytime you divide by a negative number, this inequality has to change direction. So now what we have is y is less than positive 5/2 x minus 6. So this is our equation that we need to plot. So we'll come over here to our graph. We'll start with the y-intercept, negative 6. So on our y-axis, we'll come down to 6. We'll put a dot. And then we're going to follow our slope. Because our slope is positive, we're going to rise 5 and then run 2. So we start at negative 6, go up 1, 2, 3, 4, 5, and go over 1, 2. And that will be our second dot. Now, one thing to pay attention to with inequalities. Okay, so remember, let's make a comparison here. What if I said x is less than 2? This is any number smaller than 2. You cannot pick the number 2. Okay? Here, this inequality, the y value must be smaller than this. Okay? So when we plot this line here, we're going to use a dotted line. So remember with inequalities like this, remember that we said that was going to be an open circle. So you can kind of think an inequality graph. We're going to think of that as an open graph. It's going to be a dotted graph. So let me get my ruler and we'll draw this. So here on my ruler, I'm going to go through and I'm just going to do a dotted line. Now, how do we represent lots of solutions? So this is less than. So this typically means that you shade on the left side of the graph, or below the graph rather. Okay, now let's talk about that, because I know sometimes visually the way the lines look, this can get kind of confusing. You'll see a lot in different books, they tell you to pick a test point. All right, so a test point, I always tell my students to plug in 0, 0. To me, I think that's the easiest test point. So what I'm going to do is this test point 0, 0, I'm going to plug this into my inequality. If 0, 0 makes the inequality a true statement, I'm going to shade on this side where 0, 0 is. If I plug in 0, 0 and the statement is false, I have to shade on the opposite side of 0, 0. So let's plug in 0 for x and 0 for y. So this is now 0 is less than 5/2 times 0 minus 6. So really what this is 0 less than negative 6? Is this a true or false statement? Well, 0 is not smaller than negative 6, so this is a false statement. So I'm not going to shade on the side with 0, 0. Rather, I'm going to shade on the side opposite 0, 0. So here, all of these coordinates on this side of the line are solutions to this inequality. So what that means is I could pick any coordinate point, say this one, 7, negative 1. If I took 7 and plugged it in for x and negative 1 and plugged it in for y, this would produce a true statement. And that's how we graph linear inequalities. All right, let's try another one. So if you want, you can go ahead and pause the video and you can try this and see if you can match the shading on the correct side of the line. So the first thing we're going to do is subtract 2x. And we get negative 5y is less than or equal to negative 2x plus 30. And then I will divide by negative 5. So now I have y is greater than or equal to. Remember, anytime you divide by negative 5, your inequality changes direction. Negative 2 over negative 5 is positive 2/5. And positive 30 divided by negative 5 is negative 6. So we almost have the exact same graph as we did in our first example. So let's plot this. We start with our y-intercept, negative 6. And we follow our slope. Our slope is 2 over 5, so we rise over run. We're going to go up 2 and over 1, 2, 3, 4, 5. This is our line. Now here, this is greater than or equal to. So remember, when you had that equal to in your inequality, you had a closed circle, right? So here, we're going to think a closed line. What does that look like? It's just a solid line. So let me set the ruler up. So here, I'm going to draw my line. So one way with greater than or equal to, you can think with greater than shade above the line. Now again, if some of this looks pretty easy. So it's easy to think that this would be above the line. Sometimes with the shape of the line, it can be a little confusing. It's always a good idea to try to think about this in regards with a test point. So I always recommend try plugging in 0, 0. If this creates a true inequality, then you shade on the same side as 0, 0. If this makes a false inequality, you shade on the opposite side. So if I plugged in 0 for y, 0 times anything is 0 minus 6. So is 0 larger than negative 6? And that answer is yes, this is true. So I'm going to shade on the same side of my graph as 0, 0. And remember, all this is telling you is if you picked any coordinate point on this side. So here, let's say 7, 5. If I took those values, 7 and 5, if I took 7 and plugged it in for x, and I took 5 and plugged it in for y, my inequality is always going to be true. That's going to be it for this example. I hope that you found it helpful. If you have any questions, please leave them in the comments, and we'll see you all in the next video.